Alrighty, welcome back, folks. We're going to look at our second algebraic method today on solving systems of equations. This one called elimination, and we'll get to why we call it that in a couple minutes. So let's look at this example here first. We're given a picture, two balanced scales. We have different objects on each side. So I've got a 17-gram weight on one side, a 7-gram weight on the other, cubes, cones on both sides. So if we just try to take a look at this, we should be able to logically figure out some things about these objects. So if I look at scale B, I can see a cube and a cone on one side of that balanced scale. The scale is balanced and it equals to 7 grams. Okay, that's the mass that makes these two sides equal. Now if I look at the other balance, I can see multiple cubes and multiple cones. Now if I think about this, one of these cubes with one of the cones should give me 7 grams, since that's what the other scale tells me. By the same logic, if I had 2 cones and 2 cubes, I should have 14 grams. Okay, just essentially this scale doubled. Now if I look back to A, I can say that yes, I've got 2 cones. Yes, I've got 2 cubes. Now that should account for 14 out of these 17 grams. Now if I know that, there's one object remaining and an amount of this weight that's remaining. So by doing that and thinking about it that way, I can reasonably assume that the cube has a mass of 3 grams. Okay, since I know that 2 cones and 2 cubes should have a mass of 14, the remaining object has to be the remaining mass. That just logically makes sense. Now, if that cube is worth 3 grams, I can basically take it and look over to this side of the picture. So if that cube is 3, I know I need to have 7 in total. Logically, that means the cone has to be the remaining 4 grams. By doing very, very little calculations and setting up equations and anything really, we essentially solved the system of equations. Now we did that by eliminating some objects on one side. Okay, so this is why this method gets to be called elimination, because you're going to end up crossing things out rather than substituting things in. Okay, so this says solving by elimination is an algebraic strategy for solving a system of equations. We'll be trying to get the coefficients of one variable to match, either positive or negative. Now, depending on the signs of them, that's going to tell us how we eliminate them. Either we subtract the equations or we add them together. Now, if you've got the same sign for your coefficients, so let's make a little note here. So same sign, we're going to subtract. Okay, think back to grade 8 when you learned about integers and zero pairs. Okay, if you had the same sign for the same color for your bingo chips, the only way that would work for them to cancel was subtraction. Now, if those signs were different, you had one red chip, one blue chip, you added them together to create a zero pair. Okay, so different signs meant addition. Now, throughout this lesson, we'll do both, just so you get a feel for them, but there is a way to get rid of them no matter what. Okay, so if their signs are different, one's positive, one's negative, add your equations together, and you'll create that zero pair to eliminate that variable. So let's take a look at this first system, and we'll try to solve it. Now, in order to do this method, it's helpful to make sure that everything is in the same place in both equations. Now what I mean by that is if I look at this top equation in this system and it goes the x term, then the y term equal to the constant, it's helpful for my other equation to follow the same pattern. So I can see I've got my x term first, my y term second, it's equal to the constant. So right now all the terms they follow the same pattern. Okay, now we're going to try to eliminate a variable. Now we're free to multiply equations by a constant, and that will change the coefficient of each term. Now, the goal here really is to get one of the coefficients of one of the variables to be the same, regardless of sign. So if I look at my x terms right now in both equations. One has a coefficient of 8, the other a coefficient of 3. So those aren't really the same number. I could multiply something on both equations to make them the same number, but that's going to be a little bit more work that I need to do here. If I look at the y terms, both have a coefficient of 1, okay, but the signs of those ones are different. Okay, I'm going to number these equations off like I did last time. So there's equation 1, there's equation 2. Now in equation 1, my coefficient of y is positive. In equation 2, my coefficient of y is negative. And we said before, if I add them together because the signs are different, that will eliminate my variable of y. So let's see what that actually looks like. So really what we're going to do is take equation 1 and add it to equation 2. And when we do this, we're going to add it term by term. So take all of our x's, add them together. Very similar to collecting like terms. So 8x from equation 1 plus 3x from equation 2. That will give us 11 x's, positive 1y plus negative 1y. Positive 1 minus 1 essentially gives us 0. I don't have any more y's. So I can put my equal sign. Negative 16 plus 5. I have a bunch of negatives already, and I'm adding in some positives. So I'm going to create some 0 pairs, and some things are going to cancel here. So that's going to be equal to negative 11 for us. Now, looking at this equation, really all it says is 11x is equal to negative 11. In order to solve that, I really just need to divide by the coefficient that's on x. So we'll divide both sides by 11. And this now tells us that x is equal to negative 1. Okay, without doing substitution, picking an equation and solving for a variable, and then trying to figure out what that should actually be, if I get rid of one of those variables to begin with, my job is a little bit easier here. Okay, so now I know already that my x should be negative 1. Now in order to get the y here, now it's exactly the same as substitution. Take that number for x, plug it into any one of those two equations, and it's your choice. It really doesn't matter. I'm going to choose to substitute that into equation 2 because the constant's not negative. Sometimes the negative, when we go to move it around, it gives us a little bit of anxiety, so we're going to try to avoid that negative if possible. So we're going to take x and plug it into equation 2. Okay, so x is going to go in to our second equation. Okay, that second equation again was 3x minus y is equal to 5. So 3 multiplied with negative 1 minus y should be equal to 5. So negative 3 minus y equals 5. Add 3 to both sides. So that negative y is equal to 8. But we really don't want negative y, we want positive y. So switch those signs around, and y is going to be equal to negative 8. Okay. So there's my x, there's my y. We are also asked to verify this. Since it is an algebraic method, it's possible that we may have messed up along the way. Sometimes it usually happens with a negative. Sometimes it happens just by adding. Okay, when we do that calculation in our heads, sometimes we mess it up. It's just human nature. So we'll go back in and verify it just to double check. So here's our verify step. Let's do the first one. 8x plus y equals negative 16. Plug in those numbers. Negative 1, negative 8. That should be negative 16. So negative 8 plus 8 more negatives should get us to negative 16, which it does. That one is good. We will check the other one also because we should be checking both. So 3x minus y equals to 5. 3 multiplied with negative 1 minus a negative 8 equals to 5. And this is why avoiding those negatives is sometimes nice, because there are a lot of them here. Unfortunately, for the verification step, it's hard to get away from them. So negative 3, when you subtract negatives, you're taking negatives away, which means you're getting more positive. So you're going to basically add a line, change the sign, if you remember that. So those two negatives change to positives, and you're going to be adding 8. Which means 5 equals 5, and everything checks out, we're good. So we know now for certain, so therefore, the solution is -1, -8. We're 100% confident in that answer. All of this work, showing it all, will get you full marks for that question, for that solution. Okay, let's try another one. Solve and again verify. I might skip the verification for these just to save us a little bit of time here, but I do have the answers in front of me, so hopefully if you go to verify it, you can double check that for yourself as well. Okay, so if we look at this one, we don't really have any matching coefficients this time. So the x's coefficients are different, the y coefficients are different, the constants don't really affect that. They are in the right place, so I know I can see my x's first, my y's second, my constants last. That's good. Now, we've got to come up with a way to make one of those coefficients the same. So just like we did before for general form, you could multiply an equation by something to every term, and that would alter those coefficients. Now we've got to make a choice if we want to get rid of x or y. And it doesn't really matter. If we're choosing to eliminate x, we're going to try to make the coefficients of x the same. If we're trying to eliminate y, we're trying to make the coefficients of y the same. They both don't have to be the same, just one. Okay, and what I mean by both, not x and y. Okay, so only focus on x or only focus on y. I'm going to choose to focus on x, purely by choice. And again, they're both positive, which means I don't have to work with negatives, is my thinking. So if we try to make the x's the same, we're trying to find a number that both those coefficients of x have in common. Now with 3 and 5 being those numbers, 15 seems like a good choice. So what we're going to do here is we're going to take the first equation and multiply it by something to get that coefficient of x to 15. Now if that number is a 3, we're going to multiply by 5. But we're going to do the same thing to the bottom one. We're going to try to get to 15 again, but this time my number is 5. So I need to multiply it by 3. Now notice what just happened. This will always work. If you do this diagonally, some people call it the cross, essentially this is what's happening. If you take the coefficient of one of them, multiply the other equation by it, that will get them to match, and vice versa is also true. Very similar to doing common denominators for fractions. Okay, so that's what we're doing here. Now, we're going to multiply everything and see what we get. So on top, I should have 15 x's, that was our goal, minus 20 y's is equal to 35. Okay, just remember that 5 has to go to each term, every single one, like the distributive property. For red, for our second equation, we should have 15 x's. That was why we started this whole thing, to make one of them the same. Minus 18y is equal, that should be 24. Okay? So here's my two equations now. Don't really care about y, don't really care about the constant right now. All I need to make sure of is that I have my x coefficients the same, which we do. Now, the signs of those coefficients, they're both positive, which means the only way to eliminate here, if the signs are the same, is with subtraction. So we're going to subtract these two equations. So 15x minus 15x, 0 x's, negative 20 minus negative 18. Okay, the negatives are sometimes an issue, so don't feel proud. Use your calculator, that's what it's there for. So negative 20 minus negative 18. That double negative again makes us add a line, change that sign to addition. So we should get negative 2. We should be getting more positive. So that tells us we have negative 2y's, and then 35 minus 24, that's equal to 11. Now, it doesn't look like a very nice equation to solve. It won't give me a nice whole number, but that's okay. Sometimes that happens. So let's divide both sides by negative 2. And that tells us that y should be equal to negative 11 over 2. I'm placing that negative sign on the top of that fraction just by convention. It just looks weird if it's on the bottom, okay? So we just place them on the top. So there's y. but now I've got to go back and get x. Now, there really is not a good place to do that. So since y is a fraction, I have to kind of use it in either one of these. Now, both equations are equally as challenging to work with, so it doesn't really matter which one we pick. I'm going to pick the first one, okay? And I guess the reason behind it, if I'm looking at the y value, how it's got a denominator of 2, I know if I use 4, that will simply cancel out very nicely and give me a factor of 2. If I use the 6, it would just give me a factor of 3. So it really doesn't matter which one you pick. I'm just choosing the purple one for the sake of you having a smaller number, essentially. So we're going to take y and substitute it to the first one. I guess it didn't really number them. So there we go. So 3x minus 4y equals to 7. So 3x minus 4, negative 11 over 2 equals to 7. So 3x hasn't changed. And let's go try to figure out what this whole mess is going to be. Now, when we multiply those together, just remember that 4 is a negative. So we can do negative 4 and multiply it by negative 11 divided by 2. Now, before I press enter, that 4 is essentially a fraction, okay? It's 4 over 1. Now, when you multiply fractions together, you're going to multiply the tops together, those numerators, and the bottoms, the denominators. So negative 4 times negative 11 should give me positive 44. Divided by 2 should give me 22. Okay, so that's what I should have, which is exactly what it tells me. So that's a positive. So positive 22, that's equal to 7. Now this looks like something a lot nicer, which most of us know how to deal with. So let's subtract 22 from both. So 3x equals 7 minus 22. That gives us negative 15. Okay. And again, these are the places where those errors tend to come up. Just by trying to subtract in your head, even though you might know how to subtract, sometimes you might be one off. You might just have a little blank, and you might not catch it right away. Okay, so that's why I'm just plugging them into the calculator, because it happens to us too. Just to double check, it is available, so use it. Okay, so when I do that subtraction, I get that negative 15. Divide both sides of that equal sign by 3. X should be negative 5. Okay? And my answer key says it is, so we're going to go with that. I'm not going to do the verification step just to shorten the length of the video here, but I promise you this is the answer that multiple people have gotten. So you can check for yourself for it's a little bit of extra practice. So therefore, the solution is negative 5 and negative 11 over 2. Okay, all of these questions are very, very much so the same. So get one of those coefficients to be the same, eliminate by either addition or subtraction, solve for the remaining variable, substitute to get the other one. Okay, they're very, very similar. Okay, number 3, very, very similar to the last one we did. Maybe what I'll do for this one, since you do have the answer key posted for you in your Google Classroom, I'm just going to give you the answer to this one, let you work through that one, and then you can check if you need it. So here, the solution is, I don't think it's a nice one, 4 over 5, comma, 16 over 5. So you do have a little bit of fraction work to deal with, but this should be that solution, okay? I do really want to focus on the other few that are in here, especially one that looks like this. I think our time's better used here. So looking at this one, it really looks terrible. There's a lot of stuff going on. So the first equation is 2/3 x minus a half y is equal to 4. And then our second one is half x plus a quarter y is equal to 5 halves. So this is really terrible to look at. It does not look nice at all. However, you have the tools to get rid of fractions. So So that's what we're going to do first to make it look a bit nicer. Now, if we look at the first equation, I have denominators of 3 and 2 and 1, essentially. Now, between the 3 and 2, we need to find something that's a nice multiple of both. Now, the easiest choice, the easiest thing to do, take the denominators, multiply them together. That will give you a common denominator that you could use, or not a common denominator, say a multiple you could use to get rid of both of those fractions, okay? So 6 is going to be a good choice to multiply everything by here. So that's just what we'll do. Okay, so we're going to take this one, and we're going to multiply it by 6. Now we've got to do the same thing down below. So I have different denominators, again, of 2 and 4. Now a good choice would be 8. Now you could also do 4. You could also do any multiple of those. It really does not matter how you get rid of those fractions. If I were to choose to double all 3 of these terms, okay, that would get rid of the fraction of a half, because 2 times a half is 1. 2 times 5 over 2 is 5. The issue is that won't get rid of the 1 in the middle. Because if I do 2 multiplied by what 1/4 is, okay, that's going to give me 0.5. That's still a fraction, which I'd still have to multiply by 2 again. So by multiplying by 2 times, essentially what you're doing is multiplying by 4. Okay, now that will make both of those types of fractions go away. Okay, so we're going to multiply this second equation by 4. You could also multiply it by 8, and that would absolutely work. Okay, so let's go see what we get. So on the top, when I do that multiplication, if you're struggling with the fraction operations, so 2 over 3, we're going to multiply by 6. Now this is 6 over 1. So numerators first. 6 times 2 gives you 12. 3 times 1 is 3. Divide them, and you get 4. Okay, so that's going to give us 4x. 1/2 times 6 is going to give us 3. So minus 3y, that should be minus 3y, is equal to 24. Now in purple, for our second equation, multiply things by 4. So 1/2 times 4 is 2. So 2x plus 1y is equal to 10. I'm just going to double check, and I'll show you how to put them in case you need to. So if you're going to try to do the fractions, put them in brackets. Okay, so 5 over 2, multiply it by 4. You get 10. Okay, 1/4 times 4, half times 4. Everything looks good to me. It all checks out. Now if you don't, some calculators don't exactly do what you want. Some do. Now, it's a good practice and a good habit to get into to use those brackets. If not, sometimes it's not a big deal. But when the expressions get larger and there's a lot more happening, the brackets make a big difference. So just be very careful on how your specific calculator works. Okay. Now we can try to do something with these 2 equations in red and purple. So our x's are in the same spot, our y's are in the same place, constants are together also, so that's good. Now, I don't have any coefficients that are the same. But here, I don't need to change both equations. I really only need to change one of them. So if I look at the x's, the red one is 4x, the purple one is 2x. If I multiply the purple equation by 2, that'll get me to 4x. So that's one possible step I could take. The other choice I have is to look at the y's. One of them is negative 3y, the other one is positive 1y. I could also multiply the second equation by 3 and eliminate the y's. Doesn't really matter which one you choose, the answer is the same. I'm going to just choose to multiply the purple second equation by 2. So we're going to take this one and then double it. Now notice what happened. If I multiplied by 4 in the first place and then multiplied by 2, that's the same thing as multiplying by 8. So actually multiplying by 8 in the first step would have saved me from doing the second part. We wouldn't have known that earlier, which is totally fine. It's just something that we realize going forward. So let's do that multiplication, and we're going to get 4x plus 2y equals to 20. Okay, so there's my 2 equations. Now I'll rewrite them. So equation 1 changed to being 4x minus 3y equals 24. Second one changed to 4x plus 2y equals 20. Now we can work on eliminating. So if we look at our x's, the coefficients are 4, signs are the same, we need to subtract. So we're going to take 1 minus 2. So 4x minus 4x is 0 x's. Negative 3 minus positive 2 will give us negative 5y. 24 minus 20, that'll give us 4. Okay. Divide both sides by negative 5. And again, we have an answer that doesn't really look nice, but that's fine. Negative 4 over 5 is our y value. So now we've got to go get our x value. Now, when we do this, it really doesn't matter which equation you substitute into. Okay? If you substituted into the original ones with the fractions, that is probably the best way you could do this. Because we haven't altered them or changed them, there's no way for them to be wrong. Okay? But if you substitute into something that you've altered, that's also fine, as long as you're sure you did everything right. Okay? So I'm going to choose to substitute into one of the ones we've altered because they look nicer, and I'm pretty confident that I did my work right. I say that now hoping there's no mistakes, but I'm pretty sure we're good. Okay, so I'm going to choose to plug this into the second one. Okay, so now I'm going to take y, plug it into number 2. And again, number 2 was 4x plus 2y equals 20. So 4x plus 2 times negative 4/5 should be equal to 20. Okay, so there's where I'm plugging it into, this second equation that we came up with. So 4x, now negative 4 times 2 is negative 8. Negative 8 divided by 5 is equal to 20. So I need to add that fraction to both sides. So that means 4x equals. Now, that's not nice at all. Your calculator is very helpful here. So 20 plus 8 over 5 gives you a decimal. Let's change it into a fraction. So math 1, what's my fraction? 108 over 5. Now we can divide that by 4. Now we're going to take that, divide it by 4, get another decimal, but that's fine. I can change it back to a fraction also. Divided by 4 gives me 27/5. So x equals 27 over 5. Now that can be done by hand also. So I'm going to show you that as well. So from here on, if I need to do 20 plus 8 over 5, I need to change the 20 so it's got a denominator of 5. So that's going to be 100 over 5. Okay. So 100 over 5 plus 8, plus 8 over 5, that gives us 108 over 5. Now if I need to divide that by 4, 108 over 5, if I divide it by 4, remember what happens when you divide with fractions. You flip the second one and you multiply. So I'm going to change that 4 over 1 to being 1 over 4. So 108 over 5, multiply it with 1 over 4, which gives me 108 over 20. Now that fraction can be reduced. Both are even numbers. So I should be able to divide them both by 2. Divide by 2 divided by 2. So that gives me 108 cut in half is 54. So that's 54 over 10. Now again, those are still even, so we can divide by 2 again, which will give us that 27 over 5. Okay, so totally doable by hand. Way faster if you know how to use your calculator here. Doesn't really matter if you do it by hand or not. You won't get extra credit for doing it by hand. But the understanding is still there that it can be done. Okay, the calculator is just much faster. Okay, and again, I'm not going to verify this one because of the fractions and time constraints. But if you verify it, I promise this will work out for you. So that solution is x first, so 27 over 5. and y negative 4 over 5. Okay, so check that answer key to make sure that verification is correct. Try it out on your own to know you really, really got it. Okay, so let's try a word problem that we can use this for. So write a linear system to model the given scenario. An alloy is a mixture of metals, okay? So two metals coming together to create something. An artist was commissioned to make a 100-gram bracelet with a 50% silver alloy. He has a 60% silver alloy and a 35% silver alloy. What is the mass of each alloy needed to produce the desired alloy? So I've got two blocks of silver, different concentrations. Now I have to come up with an amount of either of them to basically put those amounts together to make my concentration 50, is essentially what's happening here. So we need to do a lot here. We have to come up with the system and then solve it. So we need to come up with a way of defining some variables first. So we're going to use x and y for those variables. Now, the question usually tells you what it is your variables are going to be. So the question says, what is the mass of each alloy needed to produce the desired alloy? I have an alloy of 60%. I have an alloy of 35%. Those are my two things right there. So I'm going to need a mass of each. I need a mass of the 60% alloy, and I need a mass of the, 35% alloy. Okay, I need a piece of each to put together to make the new one. Now I can come up with two equations. So my first equation should be the masses. Okay, if I take a mass of x, a mass of y, when I add them together, I need to have 100 grams. So x plus y needs to equal 100 grams. That's the total. I take a piece of x, piece of y, in total I need 100 grams. That makes sense. Number two, the second equation is a little bit trickier to think about. That bracelet needs to have 50% silver alloy. Now that needs to be half of what that 100-gram bracelet is. Okay, that's going to be my equal sign. That's a little tricky. But I have to use these numbers somewhere else. Why would they give them to me? Now, if 60% of that x is that silver, the other 40 is the other stuff mixed in, I need to take 60% of that to figure out how much I'm going to actually take of it to have the correct amount of silver. So 60% of this is silver, 35% of this is silver, so plus 35% of y, that's going to need to give me half of this amount. The whole bracelet is 100 grams, but only half of it is silver. So I need that to be equal to 50 grams, which is the same thing as 0.5 multiplied with 100. So the first equation tells me the actual physical mass of the entire thing. The second equation tells me the amount of silver inside of that bracelet. And so they do tell me something different. Okay, and I'm just going to rewrite them just because of that number there. So x plus y equals 100, or 0.6x plus 0.35y equals 50. Okay, so there's my equations. Now, we got to choose a variable to eliminate. Now, I have to work with decimals here. That's what I'm given. Or I choose to get rid of the decimals. I'm going to choose to leave them since we haven't really done anything with decimals yet. So we're going to choose to eliminate, let's eliminate y. So we're going to take the first equation and we're going to multiply it by something that gets me to the same coefficient of y. So right now I've got 1y here, 0.35y is in the second one. We're going to multiply by 0.35. That's going to change our first equation to be 0.35x plus 0.35y. Now that's going to equal to 35. And again, if you're not confident in that multiplication step I just did, there we go. So 35, it does work out. Second equation has not been altered, so let's write it originally. So 0.6x plus 0.35y, that's equal to 50. Now we got to decide how to eliminate. The coefficients of y are identical and the signs are the same. We're going to subtract. Okay, so 0.35 minus 0.6 gives us negative 0.25x's. The y's are gone. That's equal to negative 15. Okay. We're going to divide it by that coefficient of x now. So divide by negative 0.25 on both sides. So divide it by negative 0.25. And my calculator, what did I do? Negative 15 divide negative 0.25. Oh, there we go. So x is equal to 60. Okay, so x is 60. Now we've got to go back and figure out what y is. And we're going to take x and we're going to plug it into the first equation because no decimals, no gross numbers. It's very, very nice to use. So we're going to take x, and sorry about the spacing and the organization on this one. So x is going to go into the first equation. So that 60 plus y is equal to 100. That means y is equal to 40. Perfect. Okay, you can verify it again if you need to. But there's my two numbers. That means that the mass of the 60% alloy needed is 60, and the mass of the 35% alloy needed is 40. Okay, so you've got the two pieces now. We know exactly what we need to do. Okay. If we keep on going, there's a couple more here. Now, this question is a little different. So it says solve by determining the value of each variable independently. What that means is try to eliminate a variable and figure out what the other one is and eliminate the other variable. Don't substitute back in to get the other one. So we're going to do elimination twice here. So for that first one, we've got to eliminate both variables. So it doesn't really matter which order we do this. So let's eliminate x first. So if we're going to do that, eliminate x. Okay, so there's the first one we'll do. We'll eliminate y after. So if we're going to eliminate x, we need to make these coefficients the same. My coefficients right now are 2 and 5. The number I want to get to is 10. So by eliminating x, we're going to multiply the first equation by 5. So 5 times 2x plus 3y equals 8. And then we're going to multiply the second equation by 2 in order to get us to that 10. Which means my two equations turn into 10x plus 15y equals to 40. And then the second one is 10x minus 8y equals negative 12. Now in order to eliminate that x, we need to figure out if it's addition or subtraction. So those 10s are good, they're the same. Both are positive, same sign, subtract. So 15 minus negative 8 should give us 23y's. 40 minus negative 12 is 52. Hope I did that right. I think I did. Yeah. Divide by 23. Divide by 23. Y equals 52 over 23. And again, not a nice number, but that is the one that is correct. Now I know what y is. Let's go eliminate y. And that should give us x. So if I get rid of x, I'm solving for y. If I eliminate, what can I spell? Eliminate y, that's going to give me x. So if I look at the original, my coefficients are 3 and 4. I'm going to try to get them to a 12. So that means the first equation is going to get multiplied by a 4. Now, I know I haven't talked about this yet, but you can choose to multiply by a negative if you want as well to make the signs the same, but you don't need to. Because if the signs are different, you can always add them together. The choice is yours, how you want to eliminate. The option is there though. So that's 2x plus 3y equals 8. And then 3 is what we're going to multiply the other one by. So 5x minus 4y equals negative 6. So that means that one changes into 8x plus 12y equals 16. 15x minus 12y equals negative 18. Now this time, if we look at those y's, the signs are different, so this time we're going to add. So 23x is equal to 16 plus negative 18, negative 2. I don't think I did that right. 8 plus 15 is the number I need to make sure. No, that's 23. And that means, did I do that right? 15, 8, yeah. 16 plus negative 18. Negative 2, okay. So x equals negative 2 over 23. Maybe I multiplied something wrong up top. Oh, yeah, there it is. Okay, so 4 multiplied with 8. I wrote 16. It should actually be 32. That's the problem. Let's fix that. So that should actually be 32, which means this can't be there and this can't be there. Everything else is good. Okay, so 32 plus negative 18. 32 plus negative 18. 14. That's better. Okay, so this should be 14 over 23. There we go. My apologies. Yeah, so we're good. Okay, so without substituting back in, you really could do elimination twice, eliminate both variables and find out what the other one is. That would be totally fine also. So there's my solution. So the solution is 14 over 23 and 52 over 23. Again, not nice at all, but that is a totally acceptable intersection point for this system of equations. Okay, I won't do the bottom one for the sake of it being very, very, very much so the same. I will give you the answer though. That way you have a way of checking and trying it out. So the solution is negative 1/3, comma 2/3. A little bit nicer fractions to work with. But there you have it. So you do have that solution key. I'll make sure it's posted. If you do want to try it and need to see all the steps and the work, I'll make sure that is there as well. But that is our second algebraic method. So the next time we see each other, we'll be talking about how to solve some problems using either method. Okay, so those are all the application type things. Hope everyone's doing all right, and we'll see you in the next one.